5.1, the fundamental trigonometric identities. All right, so you see on the screen a couple of the basics: the reciprocal, the quotient, sometimes called the tangent, the Pythagorean, and the odd and even identities. The top three that you see, the reciprocal, the quotient, and the Pythagorean, those are the absolute most important ones to have memorized. And I don't mean simply memorize. I mean you have a good working knowledge of them. So, and we're going to do some examples in just a few minutes, kind of to show you exactly what I mean. Those things need to be solid in your mind. If I said sine of x, then you could think of all the different things, at least to have an idea. At the beginning, it's not about having them perfectly memorized. It's more about recognition, and you bring out your formula sheet and you say, okay, I remember something like this, and you look for that specific formula, like that's the formula. And then as you practice and as you experience the different types of examples that we're going to go through, then that builds stronger and stronger recognition, and eventually you have it all memorized, or at least that's the goal. Now, it's those three groups: the reciprocal, the quotient, the tangent, and the Pythagorean. They're going to be the most critical to do what we're going to do that's at least difficult: simplifying and verifying identities. And that we're going to begin today by simplifying expressions. Really what this is about is it's about, you can look down at the example we have here: sine cubed of x plus sine of x times cosine squared of x. I need to simplify this so that I get down to, generally it's down to one trig identity, whether that or trig function, say sine of x or cosine of x, or some other function. We have several cubes or sine squares. We have two terms. We have the first part and the second part. We want to try to get this so that it condenses down to something much simpler. And when you look at this, you may think like, I have no idea what to do. And this kind of sums it up. It's always about substituting and simplifying. And at the beginning, I may not have anything to substitute, so we may have to see if we can simplify the expression first. If you can simplify, then there seems to be a lot that we can do just because we can factor something out, or we can bring two fractions together, or a lot of different things. And I'm going to give you tips, and you're going to see these tips kind of coming up, and you want to kind of put them in a place that you can look back at them. Hopefully they'll kind of ingrain in your mind, and you'll know what to do. But really what this is, the best teacher for you is experience. The more we see something like what we see right now. So the next time you see something like this, you're going to think, oh, I remember what I did last time. Let me see if that's going to work here. And then it may not. I'm going to tell you that when it gets to be the more difficult type of problems, you may find out that you may try a few things and it may not work. You may have to go back, try something different. Don't be afraid to try something, and if you get stuck, start over and try something different. Go a different direction. So let's look at the first example. I think it's pretty common that we all would agree that there is a sine of x common to both terms. So I have three different sines multiplied. Sine cubed means sine of x times sine of x times sine of x. The second part would be sine of x times cosine of x times cosine of x if I actually factored all the little elements apart. And so the first thing we can do is look for common factors. If we can find the common factors, we can see what to factor out. And if we factor out the sine of x, it looks like this. Okay? When you simplify, the goal here would really be to look for an identity to show up. Once I find an identity, then I can make a substitution that makes this a much simpler expression. For example, what we see here is what we named last week as the big boy. Here it is. Sine squared of x plus cosine squared of x is equal to 1. So that means I can remove this entire expression with a 1. And that's it. That's all I have to do. Once I do that, it's sine of x times 1. And this is something that seems trivial, but proving identity is somewhat kind of like proofs with geometry. It's a little bit formal, so putting each step in is really important, especially at the beginning. So sine of x or sine squared of x plus cosine squared of x is equal to 1. So I make that substitution, and then we multiply them together to get my final result of just sine of x. So this entire expression up here is equal to, in other words, if we were to graph this thing and sine of x, we would have exactly the same picture. They're mathematically equivalent in nature. And that's really what we're going to be doing over the next couple of weeks. It's just simplifying. And don't get me wrong, this one is very easy. There's one step and you're pretty much done. Let's do another one. Here we have a fraction. Okay, there's a couple of things that can happen with fractions. Here we have just one fraction, and we see some things on the top and the bottom. Sometimes it may seem like I need to bring parts together. Sometimes we may have fractions that need to be split apart. And we're going to look at all different kinds. So tip number 2. When you see the difference of squares, multiply it back together. Chances are you're going to see something like this. This is when you have a 1, and let me say something else. Find somewhere on your notes or maybe even on your formula sheet that I gave you last week to begin to collect all of the different varieties of the Pythagorean identities that you see. Here are 3 of them. But just to give you an idea, if I went ahead and subtracted cosine over here with the 1, then you would get sine squared x equals 1 minus cosine squared x. That's another variety. It's the same exact one, but it's just been rearranged. That's going to show up all over the place. Okay, so be careful, and it's just going to take a little bit of time and exposure to recognize those things. But begin to collect them, because sometimes they're going to show up and you're not going to recognize it. So this one, I actually want you to pause the video, and I want you to give it a shot and see what you can come up with on your own. After 5 minutes or so, go ahead and play the video back so that we can see if you can get this one without me showing you what to do. Okay, so first step, and you here I kind of gave you the clue. Multiply back together, and if you didn't catch this, this is not just it's the difference of squares, which is nice because I can multiply the top parts together. I'm going to have to FOIL all that top together, unless you remember what the difference of squares does. The difference of squares says I can multiply the top part, or the front part, and the last part, and then I just put the subtraction sign in the middle, because the inside parts, you're going to get secant, negative secant, plus secant, which gives you 0, and so the inner and outer terms cancel out with FOIL. So I'm left with this. Right? So you have secant squared x minus 1 over sine squared x. Well, we're looking for a Pythagorean secant squared x minus 1. Let's go back and look. It's not up there. However, tangent squared x plus 1 equals secant squared. There's a secant and there's a 1. Can I take this expression and make it fit into one of these? Well, hopefully it's going to be the one with secant and 1. And we can see really quickly that if we subtract 1 from both sides, you're going to get secant squared x minus 1 equals tangent squared x. And there's secant squared x minus 1. Like I said earlier, be on the lookout for the different ways this can be written. And we make that substitution, and we're going to get tangent squared x over sine squared x. At this point, remember, we're trying to get it simplified into something that is one trig function. Here we have 2. If I can get rid of a fraction, that would also be the best. The next step is to take tangent squared. If I could get rid of, well, let's go back and look up. When I say tangent squared, I think of a few things. I think, well, tangent squared is equal to sine over cosine, or tangent is equal to sine over cosine. Tangent squared would be sine squared over cosine squared. That all holds true. And tangent is equal to 1 over cotangent. So there's 2 things here that I could simplify or substitute with. Which one makes the most sense? Well, going to cotangent really doesn't really help. So here's another tip, which will show up a little bit later on, but whenever you get a chance to substitute, going into sine and cosine, or any varieties of sine squared or cosine squared, that kind of nature, you want to stick to sine and cosine. And it's not always true, but most of our formulas that we're going to deal with are going to be in some version of sine or cosine. In this case, it does make sense to use our quotient rule and to substitute. We're going to take tangent squared, we're going to make that become sine squared over cosine squared. We take this, it comes directly from tangent squared. That was our quotient identity here. And so we took that, we substituted it in. It was squared, so we went ahead and made sure both parts were squared. And so I have sine squared x over cosine squared x, all that over sine squared x. Okay, which is, if we take that and we simplify that fraction, we're going to multiply by the reciprocal. So we take that bottom part, which is sine squared of x, we're going to flip it over to get 1 over sine squared of x. And we're just going to multiply these two together, which you really quickly can see that the sine squared x's would cancel out and leave with just 1 over cosine squared of x. Now remember, we told you that we wanted to get it in one trig function. We'd also like to get rid of all fractions if that's possible. And so 1 over cosine squared is definitely one of my reciprocal function. 1 over cosine here is equal to secant of x. We've done a few so far. I hope it's kind of clear that, oh, it's easy. I recognize, and I mean, I know the functions and I know the identities. That's why it comes easier. I know what this is without having to think too much about it. Now, those are the ones that you're most familiar with. So these, you should recognize them. If you're not really secure on those, these three at the top, I cannot stress to you enough the importance of having these, I'm not even going to say memorized, of knowing them and knowing how to use them. Please, please, please do not be afraid to get your formula sheets out and look it up every time. If you're in doubt, look it up. Look it up until you're so sick of looking it up that you know what it is. And so this simplifies all the way down to secant squared of x. And we used all three versions here. We used the Pythagorean identities, we used the quotient and the reciprocal. So you can see here we multiplied it back together to get this item, and we used the Pythagorean identity to switch it out to this. Then we used the quotient identities to switch it to this. We simplified just with basic algebra, and then we had this, so we used our reciprocal identity to go from the last step to the end. So 3 different varieties of formulas here. Okay. Last example. Simplifying trig functions, expressions, 2 fractions. Okay, tip 3, let me change that. Tip 3. This is going to be a lot more useful once we get into what we call verifying. We're only at simplifying right now, so we're kind of building up our tools, our techniques for how do I simplify the expression. Eventually, I'm going to need to be able to simplify it. Not just kind of let me get it simplified, but I'm going to have a goal. I'm going to have something to get it to be exactly. And so when you have 2 fractions like this, a lot of the times it's going to be equal to a single item, a single fraction, or even a single term. And so it's nice to know that I can get these together by using a common denominator and bringing both fractions into one group. And so here again, I want you to pause the video. Take 5 or 10 minutes, whatever you need, and I want you to see if you can get this done. Remember, your goal is to get this into a single trig function without a fraction. Pause the video and come back when you're finished. Okay, so here is step 1. The first thing is to kind of get the denominators together. So that should be pretty obvious that we're just going to multiply the bottom 2 together. Notice I didn't multiply them. I'm hoping that eventually one of them is going to cancel, and so I'm going to leave them in their factored form. If I need to multiply at the end and combine that into one group, then I can. But I'll wait on that till later. And so you see in the top, you're going to get cosine squared minus sine x times 1 minus sine x. And this is tricky. I'm going to give it away just a little bit, but at this point, you see cosine squared x minus sine x plus sine squared x. I wonder how many of you almost immediately thought, oh, look, that's 1. I can bring these 2 parts together, cosine squared x and sine squared x. They're both positive, and so when I add them together, it's the big boy. Okay, this little formula will show up in a multitude of ways, whether it be in the sine or the cosine version or the other versions. It's going to show up a lot of the time. and some of you will not ever recognize it. Be careful. This is nice because cosine squared x plus sine squared x is equal to 1, so that entire thing simply becomes 1 minus sine of x. And that is exactly what we have on the bottom, which allows us to simplify it to this. So once we bring that together, cosine squared x and sine squared x to give you 1, the sine x just comes down. We see quickly that you can cancel that out, leaving you with 1 over cosine of x is equal to secant of x. So that entire expression, yet again, it's exactly the same as just typing in secant of x. If you wanted to graph each one of those, you would get exactly the same picture. This is the kind of thing I want you to pay special attention to. Go through this, look through this, make sure that you know how to simplify into these expressions.